அனைவருக்கும் வணக்கம். Now we are going to discuss about the dielectric breakdown mechanism. What do you mean by dielectric breakdown? That is the first question one can ask. The short definition for the dielectric breakdown: when the dielectric material is placed in the external electric field, we have to increase the external electric field strength. If you are increasing the external electric field strength beyond some critical value, that means maybe nearly equal to interatomic field strength 10 to the power 8 volt per meter, we can approximately say, but that's not accurate. I am saying, suppose if you are increasing beyond some critical value, some volt per meter, what it will do, the dielectric property it will lose. That means in general the dielectrics are insulators. So beyond some critical value, what it will do, the dielectric property it will break down. That is called the dielectric breakdown. Suppose here I am going to say with the diagram. Suppose if I am giving the electric field in this direction, I am just keep on tune this electric field. It is not a constant electric field. If you are placing the dielectric here, what it will do, there is a dipole generation will be there. So here negative, positive, negative charges are oriented along this field direction. Then positive charge or negative charges opposite to the electric field. The positive charges along this electric field directions. This dipole no longer will be a static dipole. What it will do, after beyond some critical field, that charges will break down. The electron will be free from the bond state, because in general in the dielectrics the electron will be in the bond state. It is not free electrons. So this bond electron, now it will be a free electron, so it will conduct the electricity. That is called the dielectric breakdown. So once the insulating property is gone, then the critical field causes a dielectric breakdown. So how many kind of breakdown it can occur, one can ask. The first breakdown is an intrinsic breakdown or avalanche breakdown. We are going to discuss both of them. The second breakdown is called thermal breakdown. The third breakdown is called chemical and electrochemical breakdown. The fourth breakdown is called discharge breakdown. The fifth one is called defect breakdown. So one by one we are going to discuss now. So the first one, we can ask the question, what is the intrinsic breakdown? So in general, when the dielectric is subjected to the external electric field, here external electric field, the electrons in the valence band acquire sufficient amount of energy to go to the conduction band, and crossing the energy gap, and has become the conducting electron. Therefore, even if you are increasing the field beyond the critical field, the external electric field, more and more conduction and electron, the valence electron, it will go to the conduction band. It will turn out to be conduction electron. So it will conduct the current. This is called in general the intrinsic breakdown or Zener breakdown. So here I want to draw the diagram for the intrinsic breakdown. In general, if you look at the dielectric, there is a conduction band. This band is called, suppose y-axis is the energy axis, the x-axis is called the wave vector. In general, it is wave vector. There is a conduction band on the top, valence band on the bottom. This is in general, it is called a CB. Maybe we can choose different color. So this is called the conduction band. This is the valence band. So the energy gap approximately for the dielectric, that means there is a forbidden energy gap. It will be 3 electron volt. If above 3 electron volt, it will be acting as insulator. So dielectric also, it's a kind of insulator, but insulator energy gap, it will be more than 6 electron volt. So it is a 3 electron volt, we can say approximately. Once if you are giving the external electric field, what it will do, the electric field, if you are keep on increasing the external electric field strength, here the valence electron, it won't be participate any conduction property. It will gain more kinetic energy. So it will just cross this energy gap, it will go to the valence band. So beyond some critical value. So now all the electron now gaining more energy in the valence band, it will go to the conduction band. So now it will be a conduction electron, it will conduct the electricity. Once this kind of mechanism is happening, this breakdown is called the intrinsic breakdown. So what are the characteristics of one can ask intrinsic breakdown? The before that we can discuss the avalanche breakdown also. So beyond some critical value, we have discussed the intrinsic breakdown is happening because the valence electron crossing the energy gap goes to the conduction band. Then now it will conduct. Now it's the conduction electron. Once if this crosses the energy gap, the conduction band property will be more for the electrons. So it acquire the conductivity. So now it will conduct. That is intrinsic breakdown. What do you mean by the avalanche breakdown? Even if you are increasing the external field, what it will do, the conduction electron acquire more and more kinetic energy. It will hit the valence electron. So it will just induce the valence electron also to conduct. That means the conduction electron acquire more kinetic energy beyond some critical value. This will hit the valence electron. Now the valence electron, it will acquire more energy from the another conduction electron. It will go to the conduction band. Now more and more process it will happen. It is a kind of chain reaction. So there is an avalanche effect will be happen. Large number of electrons due to the one electron it will hit, then another electron it will hit, it will to the conduction band, then that conduction electron it will hit one more electron in the valence band. So by that process, there is a large number of electrons in the conduction band. It is called avalanche breakdown. So here the short definition for the avalanche breakdown: the conduction electron on further application of the electric field, they collide with the valence electrons in the covalent band or covalent bond. They remove the more electrons and transferring them into as the conduction electron. This is a avalanche effect. Like suppose if you want to draw the diagram, yeah, this is a conduction band. This is a valence band. Y-axis represents the energy axis. X-axis represents the wave vector axis. So here the energy gap approximately it's like 3 electron volt. So the electrons are sitting in the valence band. Once if you are increasing the external electric field, suppose if I am applying the external electric field beyond some critical value EC, beyond some critical value, this conduction electron valence electron goes to the conduction band. So it moves to the conduction band. Now it will act as a conduction electron. More and more electron it will go to the conduction band. Now this is responsible for the electricity, no longer the dielectric as an insulator. So if you are just looking into real material, suppose if this is a dielectric material, because of the application of the electric field, the blue color dot represents their conduction electron, it's conduct the electricity. The white color dot represents valence band electron, that means it won't participate in any conductivity. So the left hand side diagram it shows the energy diagram, right hand side diagram the real material. So this the blue color dot, the conduction electron, if you are increasing the external electric field, suppose if you are giving the external electric field to the real material, it will gain more and more energy. It will collide with the other electron, this conduction electron, this conduction blue color electron, it will collide with this valence electron. So if this electron also, it will be turned into conduction electron, that valence electron. So if it is getting here, it will turn out to be the conduction electron. So what it will do, the valence electron will hit the conduction electron, it will hit on the valence electron, then it will induce this process continuously. So the more and more valence electron become the conduction electron. So then the amount of electric current passing through the material will be huge. This kind of breakdown is called avalanche breakdown. So what are the characteristics of the intrinsic and then avalanche, one can ask? The characteristics of the intrinsic breakdown and avalanche breakdowns are, it can occur at only the lower temperature. It won't occur at higher temperature. Then it requires relatively large electric fields. You have to give like around the interatomic field strength. Then this kind of breakdown occurs in a thin sample. We should not take as a thick sample. Then avalanche breakdown won't occur. It occurs with the short span of time. Within the fraction of the time, the breakdown occurs. Once if you know that the Zener avalanche diode characteristic, then it will be good for us here to understand the dielectric breakdown. The next breakdown is called the thermal breakdown. What do you mean by thermal breakdown? The name itself is saying it's due to the temperature. The breakdown occurs due to the temperature. So the short definition for the thermal breakdown here it is. So when a dielectric is subjected to the electric field, the heat will generate. This heat generation continuously dissipates. Suppose if you are just plotting this one dielectric material, take this dielectric material. So here it's a kind of three-dimensional dielectric material. What it will do, there is generation of the heat inside the dielectric material. Maybe this is thermal phenomena. It will simultaneously dissipate also, because it will dissipate the heat to the environment in all direction. Once if the generated heat, it will be exceed the dissipation heat, then the inside the electron, the valence electron, it will gain the more energy, it will go to the conduction band due to the generated heat. This kind of breakdown is called the thermal breakdown. Once if it is goes to the conduction band, then there is no longer the insulator, no longer the dielectric acting as insulator, it will conduct. So this kind of breakdown is thermal breakdown. So what it will do, again the same valence band, conduction band, the valence band, it will acquire the thermal energy, it will gain thermal energy, it will just cross the energy gap, it goes to the conduction band, then it will conduct, it won't be an insulator. So this is kind of breakdown is called thermal breakdown. What are the characteristics of the thermal breakdown, one can ask? Suppose it occurs at a only high temperature, because the dissipated heat will be lower than the generated heat inside the dielectric. So the generated heat will be larger, then definitely this the breakdown mechanism will occur due to the thermal energy. So it requires moderate electric field, no need of high electric field strength. It depends on the size and shape of the dielectric material, because if the material size will be larger, the surface area will be smaller, then the generated heat will be larger, because the dissipation will be smaller. So volume of the, compared to the bulk, that means the volume, if surface is small, then dissipation will be less. So the generated heat will be more. So then the breakdown will be occur. So definitely it will depend on the size of the material. Next point, it occurs in the order of the millisecond. So these are the few characteristics of the thermal breakdown. Next breakdown we are going to discuss the chemical and electrochemical breakdown. What is the short definition for the chemical and electrochemical breakdown means? If you look at this definition, this type of breakdown is almost similar to the thermal breakdown, but here if the temperature is increased, the mobility of the ions will increase. So that is not only the energy, the mobility also will be increased. Hence, the electrochemical reactions induced. So, because the ions, if it is mobile, then the chemical reaction will be occur in the given dielectric. So, therefore, the insulation will be decreased. Hence, the dielectric become conductor. So, this type of breakdown is called the electrochemical or chemical breakdown. So, like example, we can take the salt and water. So, if you are putting the water in the salt and water, the sodium as well as calcium ions, NaCl is the salt, sodium as well as calcium ion will be there. Then if you are increase the temperature, what it will do, the kinetic energy of the mobility of the sodium as well as chlorine ion will be increased, then definitely it will act as a conductor, good conductor in the presence of the sodium chloride. So here, what are the characteristics one can ask? The characteristics are it occurs only at a low temperature. Then it depends on the concentration of the ion, magnitude and leakage, magnitude of the leakage current. So these are it occurs even in the absence of the electric field because it's only depend on the temperature, but at low temperatures. So then if more concentration ion, then conductivity will be happen. No need of giving external electric field. That is one of the main characteristics of the chemical and electrochemical breakdown. Now, next breakdown is the discharge breakdown. What do you mean by discharge breakdown? Means if I look at this short definition, discharge breakdown occurs when the electric field contains accumulated air bubbles as shown in figure. Maybe I am going to draw the figure. When this type of electric field subject to this type of dielectric subject to the electric field, the gas present inside the material will easily ionize and thus produce a large ionization current. This is known as discharge breakdown. What do you mean by accumulated air bubbles? Means suppose when manufacturing the dielectric, here, if this is a dielectric, there will be this is the air bubbles inside the dielectric, the upper air bubbles. The white dot represents the upper air bubble. The black portion of the box represents the dielectric material. So this represents the occurred air bubbles. That means closed bubbles. This may be it's one of the defect. What it will do when we are giving the external electric field, E external, so the gas inside the dielectric it will get ionized. Maybe what it will do, the electron from the gas it will be free. So more and more electrons will generate. Then this more and more electrons will get kinetic energy. Then it will hit the another occurred air bubbles or nearby valence electrons. Then it will convert to the conduction electron. This process it will continue. So because of this breakdown, we are calling it's a discharge breakdown because charge is coming out of the occurred air bubbles. That's why it is called a discharge breakdown. So here, if you are see the characteristic of the discharge breakdown means it occurs at low temperature, then it occurs due to the presence of the occurred air bubbles. Then it depends upon the frequency of the applied voltage. If we are giving the external voltage will be high frequency, then the discharge emission will be large, the breakdown will be quick. Then the last breakdown mechanism, it is called the defect breakdown. So what do you mean by defect means? When manufacturing the dielectric, there will be a defect like air bubbles or crack, and then gases present inside the material. So when the electric field subject to the dielectric, it will easily ionize and produce large ionization current. This is known as the discharge breakdown. So in this today lectures, just we have discussed about the what is the breakdown mechanism in the dielectrics. In general, dielectric is an insulator. It's an insulator. It won't conduct. Even if you are giving the electric field, it will get polarized. But once the external electric field, if it goes beyond some critical value, then the valence electron it will become conduction electron. Then the breakdown mechanism will occur. There is no insulator. Then the dielectric it will act as a conductor. This is a mechanism is happening in all types of breakdown, even defect breakdown, discharge breakdown. So the thermal breakdown, intrinsic breakdown, avalanche breakdown, so chemical breakdown, all the breakdown mechanisms similar kind of, and even upward air bubbles also you can plot a conduction band as well as a valence band for those pulled air bubbles as well as the defects. Okay, thank you all.